Hi, I'm Molly Schreiner. I am a hydrologic technician with the USGS at the New Jersey Water Science Center. I started here in 2012 as a student intern. Today, I focus on water quality sampling and analysis. Hydrologic technicians for the USGS usually specialize in one of three major disciplines: surface water, groundwater, and water quality sampling. This video shows me and a few of my colleagues in Nevada and New Jersey performing some water quality sampling. Our hydrologic technician, Jonathan Cole, is using this DH81 sampler to collect our equal width increment sample. We are here at Delaware at Trenton for the National Water Quality Network sample. We're here about once or twice a month. Super low stage, so we're waiting about half of it today. Now let's move to Nevada to see the DH81 sampler in action underwater. One of the great things about USGS is that we have a standard operating procedure across the nation, which is great for large-scale analysis of water data.
Hello, my name is Ron Cobble, and I'm a hydrologic technician at the USGS Nevada Water Science Center in Carson City, Nevada. I've been with the USGS since 2012. As Molly mentioned in the previous clip, we often use the DH81 sampler to collect a water quality sample. Today, Bryce and I are sampling for the National Water Quality Network on the Truckee River at Tracy, which is about 15 miles downstream of Reno, Nevada. We are using a DH81 sampler with a 5/16 nozzle attached under low flow conditions. And even though we have low flow, a good portion of the channel has moderate velocity. Therefore, we attach a nozzle to keep the water entering the sampler at the same velocity as the stream. This helps ensure we capture a representative sample of water in the profile while using the DH81. This video demonstrates how the sampler vents the air while collecting the sample at one of 10 equally spaced points along the transect. After the sample is collected at the point, it is emptied into the churn. The churn is used to collect all 10 points and composite them into one sample. Bryce and I practice a clean hands, dirty hands method of emptying the DH81. I, being the dirty hands, collect the sample and hold the sampler. Bryce, with clean hands, open the churn and empties the DH81. Towards the end of the bottle being emptied, you see Bryce, he gives it a swirl to get any solid material stuck in the bottle out. Bryce changes his gloves often in the clean hands role, doing his best to avoid contamination of the sample.
My name is Bryce Redinger with the Nevada Water Science Center, and here's the churn that our samples we just collected are going to go into. Here are the bottles that we will split that water into. We have unfiltered here, and then we will filter them into these. These are labeled so the lab knows what kind of processing to do on each of these bottles. Here we've got a pesticide sample. Here's some acids that we add to each of the samples depending on what they are. You just take really good notes. Here's a time lapse of us sampling, collecting raw samples from the churn, then setting up my TPCN, which is total particulate carbon and nitrogen. We run the raw sample through a filter, collect particulate, and then the lab analyzes the filter. We do 3 of these, just for consistency. You see I change my gloves a lot. Clean hands are super important. I am now sampling inside the chamber bag to keep any dust and any other particulates out of the sample. I'll run some deionized water through my filter here to prime it. And now I'm collecting my sample from the water we collected in the river. Wipe them down, keep them nice and clean. Doing these glass bottles. These are just a different type of sample. No air bubbles can be in these guys. Nice and clean. There we go. I'm doing a pesticide sample now. Wipe everything down. Clean everything up. Put it in a bag.
Before we head back to the office, I'd like to show you a little bit of groundwater sampling. This sampling uses a pump rather than a bottle and churn like we saw in our last surface water collection video. Here's some more water quality sampling. This time we're sampling groundwater. The well water is pumped through tubing, a manifold, and into our sampling chamber, where each of the vials is filled with sample water. A few drops of hydrochloric acid are added as preservative for the sample. These vials will get analyzed for volatile organic compounds, so after the sampling is complete, they'll get packed on ice and shipped to our National Water Quality Lab in Denver, Colorado. This lab performs most of our water quality analyses. We process as much as we can from our mobile lab in the field, but right now we're going to head back to our office lab and perform our alkaline detitration and wrap up any loose ends before our sample is ready to ship off for analysis.
Hi, Ron Cobble again. Back in the office, we process an alkalinity on a filtered sample we collected earlier today. Alkalinity measures the ability of a water sample to neutralize strong acid. As seen in the time-lapse video, I am adding a known quantity of sulfuric acid to a known quantity of sample in order to determine the maximum rate of change in pH per volume of a titrant added, also known as the inflection point method.
We are just about wrapped up with our water quality sampling. The next task is getting our samples to the lab for analysis. Here's a time-lapse of the shipping process. The goal is to ship out samples quickly and securely. Each bottle and its respective paperwork is checked for accuracy of identifying information. Caps are secure and fragile bottles are appropriately cushioned. They are then tucked in ice, bagged, taped up, and on their way to the lab. Thanks for joining me and the other Hydrotechs for a day of water quality sampling for USGS.